Hello students, let's try to understand oxidation of methyl ketones by haloform reaction. This is what something called student iodoform test. Iodoform test. A student in the iodoform test, two things are there. Either you take that is I2 plus KOH, right? Or you can also take here that is NaOI. Okay, this is the second case. So in the book you are supposed to write whether you are I2 plus QH you are using or NaOI. Here general reaction is there. X means I, student. X means here is I. Keep in mind. Now see, they are saying aldehyde and ketones having at least one methyl keto link to the carbonyl carbon. One methyl group linked to a carbonyl carbon. अब see this student, what you have to see, important things that you see. This is the carbonyl carbon, and with this what is methyl group is there. Okay, so they are saying methyl group attached to the carbonyl group, that is methyl ketone group, are oxidized by sodium hypohalite. अब sodium hypohalite that is NaOX, है ना, NaOX to the sodium salt of carboxylic acid. So it is what sodium salt of carboxylic acid having one carbon atom less than that of the carbonyl compound. Now see how many carbon, 1 2 3, it is having 1 and 2, so one carbon less than the carbonyl compound. The methyl group is converted into haloform. So see here in this condition, this group, methyl group, this group is that is converting into what is the haloform. Now this oxidation does not affect the carbon carbon double bond. You see here carbon carbon double bond is there in the product, it is also there, it is not affecting in the molecule. Now iodoform reaction with sodium hypohalite is also used for detection of, this is aldehyde group, and that is 1 degree, that is methyl hydroxyl group, that is OH group. This alcohol is also giving. Now you can write there is CH3CH and OH, this group is there, nice student. This is also given by the what, iodoform. This is also can be distinguished by iodoform. So this is what is the reaction. Here you can see, student, this easily you can understand here. So this is what is the methyl ketone group. It is the methyl ketone group. It is converting into sodium salt of carboxylic acid and haloform. Similarly you can see here is methyl ketone group, it is converting into sodium salt of carboxylic acid, and here is haloform is also getting formed. This is. Now come for the other example. Okay, how can you understand this example? Let us see this example is, student. See the first one, aldehyde ketones having CH3CO group, methyl keto group gives the haloform reaction. So haloform reaction you can understand, student. Here is, this is CH3CHO and it is CH3CHO 3I2 plus NaOH. So what it is going to give, student? Here better you try to understand this one. This reaction, student. Sodium hypohalite can be used at the place of I2 and NaOH. This is the very important. Sodium hypohalite can be used at the place of I2 and NaOH. This is what. So here is what is the acetone is there, means this is the methyl ketone group. You are using with the sodium hypohalite, so this is CHI3 plus sodium salt of carboxylated plus 2 NaOH. This is what is the our product, student, right? Now if you talk about the other reaction, student, let's see some other reaction. Which of the following compound will give the yellow precipitate with the I2 and alkali, KOH? Okay, so student, that is having what, methyl keto group. Either this group is having, or that is what is CH3CHOH. If these groups are there, they are going to give the yellow precipitate with I2 and alkali. So methyl acetate, acetamide wrong, 2-hydroxyl propane, and here is acetophenone. So it is given by acetophenone most probably, student. C and D, correct option is C and D. So 2-hydroxypropane. Acha, this is going to give, student. Why, student, 2-hydroxypropane? Because it is having what? It is having what group it is having, you can see, student, what group. So it is the methyl hydroxy group. This group and this group give this test. So the correct option is option number 2, C and D. Here you can see, student, CH3COR is oxidized by NaOI to form the iodoform, and here is methyl acetate and acetamide will not give yellow precipitate, but 2-hydroxypropane and acetophenone will give yellow precipitate. So acetophenone will also give, student, acetophenone. So these two are the options, student. Now next one, methanol and ethanol are distinguished by methanol CH3OH and ethanol CH3CH, and here is what is, that is OH. So this is what the group, student. Okay, this is the methyl hydroxy group. So it will give the iodoform test and it will not give I2 plus NaOH. This is iodoform test giving, but it is not given. So treating with cyprin, no. Lucas, no. Heating with iodine, option number C is correct, student. So option C, methanol and ethanol are distinguished by type of test known as iodoform. When ethanol is warmed with the iodine in presence of NaOH, it forms the yellow color precipitate, but methanol did not react with positively to iodoform test. Next one, which of the following pairs can be distinguished by iodoform test? So that is, these two will give iodoform. Okay, which of the following can be distinguished by the iodoform? So both are giving, so it cannot be used. This both will give, so it cannot be used. This can be used, student, because methanol will not give the test, it will give the test. Let us see the option. Option C is correct. D is also HCHO and CH3. This will not go and this will give, student. So correct option will be option C and D, student. Okay. The iodoform test or iodoform reaction is qualitative chemical test for detection of the methyl keto alcohol carrying an alpha methyl group. The reagent are iodine and sodium hydroxide. Only methyl ketones and alcohols with the feature CH3CHOH are may undergo these reactions. So this is all about the iodoform test, student. I hope it will be helpful to you to understand. Thank you so much for watching, students.